13.3 goes over geometric sequences. Your geometric sequence, you worked with arithmetic sequences, which worked on addition and subtraction with your changes from term to term. These changes in your geometric sequences are going to be multiplying by either a whole number, a negative number, or a fraction. Remember, your fractions represent division. So with these, you have a common ratio. That common ratio is represented by the variable r. Your a sub 1 is still going to be your first term. Your a sub n is going to be the term that you're finding, the nth term that you're finding. Your formula for your geometric sequences is given to you as a sub n is equal to a times r to the power of n minus 1. Your a, that's on the right side of that equal sign, is your first term. That's a sub 1. Your r is your common ratio. You can find that common ratio by doing your third term divided by your second term, or something like your first term times what is your second term, and then if it's the same as for all of them, that's your common ratio. And then that n is the number of the term you're finding. So if we look at an example, if we're given that a is equal to 3 and r is equal to 2, with our geometric sequence, we are going to write the rule and then find a sub 17. So a is 3, r is 2. If we're working with geometric sequences, we're working with the formula a sub n is equal to a sub 1 times r to the power of n minus 1. Your a sub 1 is 3, so that's going to become a sub n is equal to 3 times r, which is 2, to the power of n minus 1. We are not going to multiply that 3 times the 2 because that 2 has the power on it, the 3 does not. So that 2 and that 3 have to stay separated. You can't multiply them together. So your rule is this a sub n is equal to 3 times 2 3 times 2 to the power of n minus 1. If we are finding the 17th term, we can find a sub 17 by doing 3 times 2 to the power of 17 minus 1. You're going to need your calculator for this because it is going to be working with a larger number. So you can simplify that power to be 3 times 2 to the power of 16. The 2 to the 16th power is 65,536. So we're going to do a sub 17 is equal to 3 times 65,536. From here, we just multiply by 3, and that gives us our answer of 196,608. Next example, we have the sequence 2, negative 10, 50, negative 250, 1,250. So to get our r, remember r we said is the third term divided by the second term. That's going to give us 50 divided by negative 10, which is negative 5. So r is negative 5 in this case. Our a sub 1, or first term, is 2. So if we plug this into the formula, a sub n is equal to a sub 1 times r to the power of n minus 1. We're going to have a sub n is equal to 2 times negative 5 to the power of n minus 1. So that's our rule. To find a sub 24, we're going to use n as 24. So that's going to give us 2 times negative 5 to the power of 24 minus 1, which would give us a sub 24 is equal to 2 times negative 5 to the power of 23. Now, if you use your calculator for this and you do the negative 5 to the power of 23, you're going to get a number that is negative 1.1920929 times 10 to the 16th power. Instead of working with that, you're going to multiply it by 2. And you're going to get yourself to where you have a sub 24 is equal to negative 2.38418,579 times 10 to the 16th power. We're going to keep this as our answer. The reason why is because if you did simplify this using that 10 to the 16th power, you're going to get an estimated number. That 16th power means to move your decimal point 16 places to the right. Well, if you do that, you're going to have to add in zeros. And that doesn't necessarily mean that that exact number is correct. So leave it as the negative 2.38418,579 times 10 to the 16th power. For the next example, we have the sequence 1, 1/3, 1/9, 1/27, and 1/81. If we divide the third term by the second term, we get 1/3. You can also say that 1 times 1/3 is 1/3. The 1/3 times 1/3 is 1/9. The 1/9 times 1/3 is 1/27, and so on. So your R is equal to 1/3. If A is equal to 1 and you're using your A sub n is equal to A sub 1 times R to the power of n minus 1 for your rule, you're going to have A sub n is equal to 1 times 1/3 to the power of n minus 1. If we find the 9th term, we are going to use A sub n, which is A sub 9, is equal to 1 times 1/3 to the power of 9 minus 1. Now that power of 9 minus 1 is 8, so that's A sub 9 is equal to 1 times 1/3 to the 8th power. Instead of typing this into your calculator, you're going to have to take that power, put it to each, the numerator and the denominator, and simplify it there. If you put it into your calculator and try to get your calculator to go from decimal form to fraction form, because it tells you no decimals for your answer, it's not going to give you a fraction. So you're going to have to actually take that power and apply that power to both the numerator and the denominator to give you A sub 9 is equal to 1 times 1 to the 8th power over 3 to the 8th power. The 1 times anything is just that term that we're multiplying the 1 by, so I'm going to get rid of that 1 in this next step and do A sub 9 is equal to 1 to the 8th power, which is 1 over 3 to the 8th power, which is 6,561. For your next example, you are finding the common ratio, the first term, the nth term, and the 8th term of the geometric sequence 5, 15, 45, 135. From 5 to 15, we multiply by 3. From 15 to 45, we multiply by 3. From 45 to 135, we multiply by 3. So R is equal to 3 in this case. Your A sub 1, or your first term, is 5. So your rule for this is going to be A sub n is equal to 5 times 3 to the power of n minus 1. Your next thing that you're finding is the 8th term. So A sub 8 is going to be 5 times 3 to the power of 8 minus 1. That simplifies to give you 5 times 3 to the 7th power. That 3 to the 7th power simplifies this to be 5 times 2,187. And when we multiply, we get our 8th term to be 10,935. When you find the partial sum of a geometric sequence, you are going to use the formula S sub n, which, like I said, is this partial sum, is equal to A sub 1 times 1 minus r to the power of n over 1 minus r. Your r is still your common ratio, your A sub 1 is still your first term, and that n is still the term that you're finding. So if we look at an example, we're going to have the geometric sequence 1, 4, 16, 4096. To find r, we multiply the 1 times 4 to give us 4. The 4 gets multiplied by 4 to give us 16. So R is equal to 4. Your A sub 1 is the first term, so that's 1. So remember, your formula was your partial sum is equal to A sub 1 times 1 minus R to the power of n over 1 minus R. I like to put parentheses around that fraction. I would do so if I were you. From here, you don't have n, but you have the last term. So you can use your rule that we worked with the questions that we worked on before this in order to find n. That formula would have been A sub n is equal to A sub 1 times R to the power of n minus 1. We know what A sub n is because that's our last term. That's the 4,096. Our first term we said is 1. Our common difference, our ratio here is 4, and we have n minus 1. In order to solve for n, you're going to have to move the 1 over first. So that 1 is being multiplied by 4 to the power of n minus 1. So we're going to divide each side by 1. That doesn't change anything about this other than the 1 being eliminated. Now, if you think back to when we first started talking about logs within this course, we said that if your base is the same on both sides, they cancel out and your powers remain. So we have to try to turn that 4,097 into 4 to the power of something to make sure the bases are the same so we can cancel out that 4 on the right side, and then we'll be able to cancel out that 4 on the left side.
497.
Oh, it should be 496. I'm sorry. This should be 496. Sorry, thank you. So this is 496 is equal to 4 to the power of n minus 1. So to find whatever 4,096 is as 4 to the power of something, we're going to take that 4,096 and divide it by 4 as many times as we possibly can to get it just to be 4s. So that's going to be 4 times 1,024. If we divide that by 4, we get 256. The 256 divided by 4 is 64. 64 divided by 4 is 16. And 16 divided by 4 is 4. So we have a total of 1, 2, 3, 4, 5, 6 4s. So that's the same thing as saying 4 to the 6th power is equal to 4 to the power of n minus 1. Now your base is the same on both sides. So those bases are the same. They cancel each other out. And we're going to have 6 is equal to n minus 1. We want n. So we're going to move the 1 over and add it to both sides. And we get that n is equal to 7. Now that we have n, we can plug that into our partial sum formula and solve. So if we do that, we're going to have the partial sum. So S sub n is equal to A sub 1, which is 1, times 1 minus R, which is 4, to the power of n, which we said is 7, over 1 minus 4. That 4 to the 7th power gives us 16,384. So we're going to have S sub n is equal to 1 times 1 minus 16,384 over 1 minus 4. So we're just going to simplify this. And we're going to have 1 times negative 16,383.
You're welcome. Enjoy it.
Over negative 3. So from here, your double negatives on the top and the bottom become positives. We divide by 3, and we have 1 times 5,461, which is just 5,461.